let me just post a comment and see whether anyone's there. We give people a few minutes just to show up before welcoming people and that sort of stuff. Let's see. Any noise in the background is probably from my kids.
I'm sure mine will come running in and bang the door any minute now.
Yeah, you saw my son run through before. My office is also a corridor sometimes, so but they're meant to be staying out at the moment.
Mine has chocolates in it. That's the problem. So.
Oh no.
So you work that out.
It looks like we have Lord Teaspoon at least here, so that's a pretty good start. I think we've got a decent audience now, so let's start off. So welcome to the March Sydney Alt.net meetup, and today we've got Param and Jason going to tell us about Dapr, but and also show us a bit of a demo too. We don't have Richard because he's sick, but I'm sure we'll all succeed and carry on regardless. So we also have the usual JetBrains competition, so make sure you stick around till the end and I'll save some questions. I'll listen carefully, as you should be as well. And there'll be 2 questions for the JetBrains licenses. And whoever answers first will get the licenses for 1 license per question and only 1 license per person to any of the JetBrains products. All right, anyone else want to chuck in a comment to say that they're alive and ready, and then we'll soon get started. Let's see, or anyone want to chuck in any news or anything that's come up of late? Feel free to put it in the comments. It's a quiet group today. Here we go. All right, sounds good. So I'll start bringing up the screen share. So what's up to the side here? It's not my kids in the background, I don't think. Presentations from home. All right, I think we're good. All right, so I'm very pleased to hand over to Jason, who's going to be starting the Dapa presentation. And I was very pleased when the team of 2 decided that they'd be able to present to us, because Dapa is something that I know the group's quite interested in, and we have quite a lot of people expected tonight to listen in. So we did actually have someone else who was thinking of giving a presentation on Dapa because it's such an interesting topic, but you 2 guys actually got in first, so you are the star presenters on this. So, and I don't know, you going to tell them a little bit about your work? It sounded quite interesting as well before you go into the Dapa, or up to you really.
Yeah, well, that kind of has a bit of context. I mean, tonight is an introductory talk, so if you just kind of bumped into the word Dapr or saw a few updates on a feed and wanted to have a good sweeping look around at it, then this is the talk for you. If you've installed it a few times and done a proof of concept, then probably you'll feel like this is a bit light. We particularly became interested, Param and I, working on software architect for a new project that we were rolling out internally in Pacom. Pacom has very particular requirements because we do physical security. Like I was mentioning before this, that if you need a security system added to a nuclear power plant or to a prison, and you need that thing to be completely off the grid, air gapped and all that kind of stuff, we need to offer support for that, as well as software as a service offerings as well for people who are just running a security, like a gym, like a 24-hour gym, and you got a badge in. So we got to scale from those two extremes. And so all the non-functional requirements that come with that, we started looking down the road at Dapr, and this talk was kind of a breadth of getting started with Dapr, and Param will be doing a demo of a simple kind of microservice hello world to show you Dapr and how it fits together. So happy to get rolling. Usually what people are facing as developers is they do fully well know that they need to make sure their apps scale out and not just scale up. And that's becoming more and more of the world we live in, and cloud only makes that even more important. Everyone's looking at microservices and how they can break their apps into microservices, but you need to make sure they're resilient microservices, that they scale, and you're not just creating a whole bunch of network latency between these services for nothing. You want to be able to focus on building your application. It particularly when you're looking at joining all of these pieces together, you can get bogged down in infrastructure work, in the plumbing side of the communications and things like that. We also, if you're lucky enough, like if you've got a bit of taste for Lambda or Azure Functions, or even Open Function now, which is a platform that the cloud initiatives are doing, the idea of running your code without even worrying at all about the provisioning of server resources or cloud resources is a growing trend. And lastly, multiple languages and frameworks. Now, your shop might have a particular set of languages they support. It's going to be something that every developer, like over the coffee, they'll be talking about, have you tried out Golang and all this. You kind of get tied down to what the organization is supporting. But if you need to use the right language for the job, for example, you need to get some Python or R scripts for some machine learning stuff running, but you need to get that plumbing working with some Go modules that you've got for some of the database or some of the network stuff or telemetry collecting and things like this, then this is a problem that you might find sooner rather than later. Now, microservice development itself has a few issues people find adopting it. It says here limited tools and runtimes. Now, when we say that, it's kind of like, you've got service meshes, you've got kind of platforms that say here, if you build your microservices on top of this, we'll help you work. But it's quite limited, and particularly ties you down in terms of what platform you're running on or what language you're running on. So, for example, this supports like a C#.NET world or a Java world, or they're kind of looking at the world from those points of view. Or this is really tailored for AWS or Azure and tying you down on the infrastructure portability. Now, of course, when we're talking about microservice, what are we talking about? It's everyone will be used to this by now. It's broken down these services. So we've got like a front end service. We've got email broken out. A shopping cart service has a bit of storage, like a payment gateway. Checkout, in this case, talking to Cosmos DB and shipping with Kafka. So you could be using different data stores or message broker, message bus systems. Maybe you need to kick off remote commands into third-party systems to kind of triggering things. And again, like inventory service with its own state management. This is the kind of thing that you're seeing, as you're breaking these things apart. And we're going to be talking about this and how we can help with this. So Dapr stands for Distributed Application Runtime. As I say, it's designed to be portable and event-driven. And importantly, in our case, we were, interested in it being on cloud and edge. So that was something important to us. We weren't locking ourselves into the cloud, but we wanted to be able to use the cloud as best we could. Now, Dapr in general has a few pieces that are kind of the guiding principles, best practices around building blocks. Now, we'll talk about building blocks a lot in this presentation. Consistent, portable, open APIs. Now, that consistency of the APIs and is a big piece of this, which we'll get into. Extensible and pluggable components. Now, I'm going to fast forward a little bit because we're going to demo a lot of this stuff, but when you see any language or framework, you're probably wondering how could they be doing that. Standards like the Open Telemetry standard, there's even cloud events, things like that they've adopted. And then community-driven or vendor-neutral. So this started off in a Microsoft kind of world, and since then it's been moved open to the cloud native project to try and drive this and kind of bring a kind of a independent steering committee behind it and kind of free it from any ties, particularly to Microsoft. Now, any languages and frameworks, the way this is done is you can write your microservices in Go or Node or Python, .NET. It's independent of that. What really happens is you're communicating to Dapa via a HTTP call or a gRPC call. So you'll be hard pressed to find any modern language that can't do a HTTP call, and gRPC is pretty common too. But I mean, HTTP is pretty universal now, and through those calls from your microservice, Dapr is going to provide you with service-to-service invocation, state managed, pub sub, all these things. The way that works is as a sidecar library. So if you're familiar with that Docker design pattern of having a sidecar, often you'll see it in some telemetry components where they'll kind of sit on the side and instrument your messages, or maybe provide a kind of a security facade around your containers. So Dapr follows that pattern, and we'll go into that a bit more. So Dapr provides these building blocks, which you'll find a very good abstraction and kind of way of splitting out different parts of work in microservice world that you're going to want to do. And we'll drill into each one of them. But if you think about it, how much are you doing service-to-service invocation between your microservices? That's core. State management, core again. Pub and sub, you've got your broker there. This is a core resource to have. Triggering events and things like that. And Dapr provides these out of the box. And again, any cloud or edge infrastructure. Now, edge infrastructure is just the cloud word for on-prem, or in IoT as well. You can run it inside of, if it can run Docker containers, it can run Dapr. So, your edge infrastructure, even a Raspberry Pi these days can run Docker containers. So that actually has expanded quite a lot. And in the security work that we do, we are interested in what we call controllers, which is a hardware device which works to collect all the alarms and sensor input and stuff like that, like very IoT kind of world. And so that's also interesting to be able to push things out to there if needed. Again, the sidecar model is that your application, in this case, we're talking about a microservice and a Dapr sidecar, they go one-to-one. So for every microservice you have a sidecar, and Dapr exposes an API, which again it can be HTTP. Obviously, that's good for kind of like intercepting messages and seeing what's going on. gRPC is good for the performance, lightweight and binary protocol like that. You can switch to them as you wish. Here's a few examples of what it looks like, what this abstraction looks like. So in this case, we're doing a service invocation. We're saying, hey, can you invoke for me on the cart microservice the method called new order? And that's just a post, as simple as that. And Dapr is going to pick up that and route that over to that service. Another example for state, again, the URL syntax is quite simple. It's very easy and fast for people to get their head around this. Publish for pub sub, secret management, which is a very important one we'll go over, and retrieving a password from a key vault like that. So think of every one of your microservices as having a little Dapr sidecar. And then between service A and service B, Dapr is going to provide state management, service invocation, the message bus, secret management, and all these nice things for you just by including Dapr as a sidecar in your application and calling it through that URL syntax. So we'll be drilling into that in this talk. Now, that abstraction layer is driven by YAML files, and I don't expect you to get your head around that straight away. We're going to show you an example for state stores and pub sub, etc., and then it'll become quite clear. But the power of that is that these components being driven by YAML files allow you to have very pluggable state stores and pub sub brokers and bindings and triggers. So, it's very easy from an architect's point of view to get bogged down in what kind of state store you're going to be using, or you might need to transition your state store depending on if you're on-prem, depending on how you're growing, depending on the cloud that you're invested in, or the message buses that are available. And Dapr really does a great job of exposing these components. And of course, if it seems like something that you think you want to contribute back to the community, this is a great way to contribute back, is by writing a component that plugs into Dapr. We were talking about one for identity server. This is a ever-growing list, and probably once you've got that infrastructure in place, the most exciting part of Dapr is being able to work with these components, and we'll show you just how easy that is. Again, I'll speed through this. It's not so important that Dapr has these building blocks. What's really important is that when you're working in a microservice architecture, when you're going to need lots of these things, and if you don't need a message bus today, well, it's only probably a matter of time. Or if you need to trigger output to some Twilio kind of messaging or something, that's only until marketing and gets their hands on your app and says we need to do this integration. And so service to service invocation is the core one and the easiest one to get your head around to get started. Say, for example, you got the service A here, and you want to call method new order. You're going to post a bit of data, which is just hello world. Then what your application will do is just send this HTTP post. And Dapr will do all the work of discovering where is that component. So service discovery is always an important part of a microservice architecture. It uses MDNS, so multicast DNS, for service discovery on the same machine. There are other ways for it to do service discovery as well, but that's kind of the easy one if they're all running on the same virtual machine or via Kubernetes. They have a way for that. Mutual TLS encryption. Now, this one, I think a lot of people might be rolling their services and punt on this one. So encrypting traffic between the two sidecars automatically for you and rolling certificates every day. So your communication between your services is that much more secure, pretty secure, right? TLS, encrypted security between those, and the certificates are managed for you. And then finally, that is received on service A as a post to the new order endpoint, which, if it depends on what language you're using, but your service might ask for that post to be passed in like in ASP.NET Core as a web API that gets called. There are SDKs to make the Dapr integration nicer for whatever language you use. So, Python it'll be completely different, but you'll have some routes or whatever you're going to get these messages back on to work nice with your system. And then, of course, you can talk back. The state management, I love the state management example because this was a real big issue when we were looking at the cloud scaling and how to keep things simple for the on-prem. Say your app wants to store something to a Redis cache, then you're just saying, I want to store some state, and I want to store it in what we've happened to call corpdb. But that's not a connection string to a database. That's not a SDK that you're calling to do this. You're posting a little key value pair. So this is assuming a key value pair data, but this is posting that off. And in this case, Dapr is being configured to use Redis cache. But also I should say, get is just as easy, HTTP get, go get me the planet, return dev star. But you deploy that now into Azure and your scaling means that you want to use Cosmos DB to get down to that millisecond latency, or you need data centers around the world and you want to distribute that data and you didn't want to configure the Redis to do that. And then you can switch it out to Cosmos DB. Now the thing here is that no change in your application code happened. No change in your microservice happens during that point. That's a YAML document configuration change, which I'll show now. So the state API, like all the APIs, they're featured the way you'd expect the save, stay, retrieve, delete, even bulk gets and even transaction support. But this here is the Redis YAML file. What you're doing is you're defining a component, you're giving it that global name, corpdb. In this case, it's Redis. And then this metadata, the configuration here, is the part that's doing the whole Redis side configuration. So it's not in your code. And that division of labor, that splitting of the developer, what they're working on, and the infrastructure is not just appealing for the developers to simplify what they're working on, but that's appealing to the architect who might not want to just nail it down to Redis, for example. And that's appealing also to operations who may need to switch it out, into a different provider and being able to do that. All of the information is for that connection strings and passwords are stored in the YAML file. And if you see here, it supports the secret store as well. So your configuration files aren't going to cause you to have to do a breach kind of report to all your customers saying that your password was checked into GitHub source control or something. So your secrets are kept secure as references, and Dapr has support for secret store, so we'll cover that. But that kind of best practice of making sure that you're not hard coding passwords and stuff is even in the YAML files, which you want to version control these. You want to have these checked in and kept track of, and infrastructure as code kind of deploy these along with the whole infrastructure and things like that, but not expose passwords, of course. Now switching that out for Cosmos DB is just as simple as that. You say the type of configuration now is Cosmos DB. here's my connection string now, and here are my passwords, etc. in the database that I'm working with. That's a huge win, that you're not switching out the NuGet packages that your application is using to do that, or linking in both packages just because you need to switch, or all of that kind of stuff, or needing to redeploy those services because you have a new build because you switched out the providers, and on and on. PubSub. So you got your app again, the sidecars, this time service A and B. You've got a Redis cache working as the message bus. We've got a post to publish. In this case, publish is the keyword in here. We're going to publish to the orders into the process queue. We're passing in the hello world, and then the services can choose how they want to retrieve that information. In this case, for service A, he's going to retrieve that on orders. Service B is going to pull that out from factory orders. They kind of choose how they subscribe, and the plumbing internally of that. It's a very simple API. Again, you publish a message through publish, putting it onto that queue. In the sidecar, pushing that to the application, there's a subscribe call. And if you're in the ASP.NET world, that will trigger a controller saying, hey, this is what's been published, and you can feed from that. If you want to publish messages back, then you're just posting. The configuration in this example for the Redis pub sub is, again, you're passing in these credential kind of things, connection string kind of things, what topics you're subscribing to, that kind of configuration, external to the source, external to your microservices, which is the key. And of course, I could have shown more different, I could have showed RabbitMQ and all that as well. Input triggers, this is, talking to the world, pushing information to you. So in this case, binding to Dapr, through Dapr to Twitter. Say you want to be subscribing for new tweets and getting that data pushed in, there's an input trigger for that. And output bindings as well. Like Twilio, you need to text that to someone. There's bindings for that. Now, it doesn't draw it. This two slides didn't make it clear that that's the beginning of a kind of function as a service. Kind of a platform for you to write just your code and have things trigger them to run, and then have the output come back out, and that kind of thing. So if you wanted to go as that function as a service route, then this is a way to get started in that kind of area. What does that look like? Your Twitter YAML file, you just, bindings is the keyword. In this case, you're posting or put information to bindings into Twitter, which is just named here. Or if you wanted to post a tweet, so output invocation, or you're getting posted in new tweets. And the configuration, what you'd expect from Twitter, you expect to have consumer keys and access tokens and that kind of stuff. And again, you keep that stuff all secret in the secret store, and Dapr is going to do the work of accessing that and retrieving that at runtime. Okay, so secret store. So, this is when you're deploying stuff and you need to make sure that handover is very solid. In some industries, you kind of have to, by regulation, make sure that those secrets that production secrets are not available to development team at all. They have very clear staging and teams, etc. And how do you keep that nice and clean? Dapr has an API for secrets. That's example is HashiCorp, but that, there's even a secret store in Kubernetes that you can easily use as well. The keyword on that one is secrets. And then we're calling out the vault component to get the my secret, and that returns the super secret value. So this is a get. I mean, it has been pointed out to me that this doesn't do like a post. So Dapr is really providing you with a way to retrieve secrets, but not a way to set secrets, which would require kind of, key, better security kind of conditions, I believe, than what Dapr is supporting. So you can retrieve the data securely, but you're not going to like write a new key to the store and all that kind of handshake. So if you're building a system where you need an administration portal where you can set secrets up, then Dapr is not going to provide you with that administration portal kind of experience. You're going to need to think about that part of how did you create in HashiCorp the permission to even have a secret key, that kind of stuff. So there's a slide at the end where we talk about how Dapr fits in compared to things like service meshes, but I think it is worth pointing out the secret stuff is it's not a one-stop shop for abstracting secret management. It's only just to retrieve them, and I think that is an important thing to point out. Yeah, so you can plumb these secrets into your say again. I come from a bit like the .NET world, so and this user group is kind of alt.NET, so it's a perfect group. But if you need to retrieve these secrets as part of your app start kind of loading of configuration to go and connect to databases and things like that, there are nice NuGet packages that wrap this functionality and plumb it into the configuration provider in ASP.NET. But if you have to talk in another language where you don't have this library, and they do build SDKs for a lot of languages, then you're just simply doing a get call. On a little IoT device, being able to just say get from the secrets, the vault, my secret, and get back that information. I mean, you're looking at a very lightweight system by doing that. The vault itself is handling the configuration for Vault, I should say, is handling your certificates and the PEM files and the public keys and all that kind of stuff to access those secrets. And again, keeping it out of the the developers aren't copying these files over and all that kind of stuff. Virtual actors. Now, I'm sure a lot of you have heard of Orleans and Project Orleans and actors and some languages that support actors better than kind of C# world. But there is when you're working with microservices, you're tending to make a kind of a service for a particular functionality, and you kind of scope it quite cleanly. Like, this is going to be my order processing. This is going to be the email lodging kind of communication backend piece, and etc. But there is a different pattern. In the IoT world, it comes up a lot, where you need to have, you kind of want to have something stateful object that represents each one of those devices on the field. And while it's true that Orleans will probably give you a better way of doing actors, if you need to kind of if you wish you could kind of take a microservice and make it kind of stateful, make it have some of these active behaviors, then Dapr actually helps you with that. I really think they've taken a lot of lessons they learned from Orleans and pushed that into here. As part of release checklist of Dapr, they do a huge scale test of their actor framework, raising it to 1 million actors. If you're working in the microservice world and you've got like 10 microservices, 20 microservices, and then some design of yours says, I'm going to need 100, 1,000 microservices, then your team's going to wonder what's gone wrong with you. The actors is the place to do that. And so you can have a look at this for the durability of state management and running and loading on different machines. I'll talk a little bit about that. So one of the canonical examples was in Halo, when they wanted to deploy like artificial intelligence characters, and each one of your video game enemies would keep track of the score, where they're at, what weapons they have, and all that kind of stuff. It's kind of stateful. And you want to kind of distribute that processing so that you know that there is processing dedicated to each one of these guys. You don't have to worry about how you're going to handle the processing for each one of these guys. And that can be distributed across many different pods. And then if one of them goes down, because of the stateful persistent nature of actors, that can be redeployed on another pod through what Dapr calls a placement service without you doing anything. And that's the key. You're not doing anything to make that work. And so that service fabric reliable actor pattern is something that you can set up with Dapr as well, if that's what you need, or if that becomes interesting to you. And it may not be something you're interested in. In the actor world, they've simplified it so that the keyword here is actors. You can instantiate an instance of myActor by just calling the myActor service and name. A here is just giving it a name. It's so lightweight the way it's done that if you just give it a name, if it doesn't exist, it'll create one, but a brand new one. But if it doesn't exist, then you'll new one up and then call that method, update method on that actor A, setting the speed in this case. So that kind of system, Dapr has that actor placement service that keeps a track of that. Did I miss something? I think there was an example of that pod going down. It'll switch over to this pod, but I think the slide got broken. Actor placement, because obviously if you've got a lot of these things running, you're going to need to make sure they scale out on hardware. I'll just point you out to the actor APIs. I won't dig into them. Observability. Now, we have a new project internally where we've acquired some technology, and they need to get better visibility in what's happening between their services, and to get that telemetry and understand it better. So when you have Dapr working as a sidecar for the communication in your system, then that's naturally a good place to start doing some telemetry. And Dapr supports open telemetry collectors, which, it's going to include the one you like. If you like Datadog or Zipkin or, App Insights, it's going to be supported there. And then you're getting that view of what's going on in your system, which in the microservice world is so critical. Distributed tracing. Out of the box, they built Dapr can run locally as an executable, but it also, the hello world kind of brings down a bunch of Docker containers. And one of them will be a Zipkin Collector, just to help you get the idea of what's going on in your system. So a Zipkin Collector, it's optional, but as a hello world getting started, it'll pull down a Zipkin package and then give you a view of how your system's going, the number of calls. In this example here, it's a calculator front end. Param's going to give an example, which is very similar for a Fibonacci kind of a statistics app, like a little statistics microservice thing. But distributed tracing, that's what you're going to want running the system for real, and you can configure the sample rates. Dapr exposes a bunch of metrics. Now, if you're in production, you need to know how things are going, how CPU and RAM are going, and all this kind of stuff. This is a good operations view that is built into Dapr to give you an idea. Call latency from cart to cart is covered. I believe that also covers a bit of the service itself. Well, actually, no, I'm thinking about resiliency. So there is a piece on this which is called the middleware. I think I don't actually have the slide on it, but because Dapr runs in the middle of your all your communication, they're a middleware for retries, and so that helps with your information on error rates and system health and things like that as well. You know, you do your little ping to your service, and it can report the system health. I mentioned that there's Dapr in it, is the way that you get it running self-hosted. You know, that's going to pull down Zipkin, Redis, and as Docker containers, and Dapr Run is going to wrap up your services as sidecarts, and then you're up and running. Or Kubernetes is the kind of the cloud preferred way of doing it. So there are people who run Dapr in a pure virtual machine environment, not in a Docker environment and not in a Kubernetes environment. But you want cloud scale, you want to go with the Kubernetes, and work in that world. And Param's going to be demoing it in Kubernetes today. You can even run it outside of Docker if you want to debug. Like, you want to run it on your local machine, just do a little bit of debugging and stuff like that. You don't have to run it in Docker at all. This is what it looks like. Works on, you say Dapr run and give it the name of your application, and it's going to launch Dapr and kind of wrap your application and all the communication there, and do the work of connecting all those services, and the YAML files for your components will be connected as well. For Kubernetes, it's as you'd expect. You've got your pod running your application. There's these core services that Dapr also provides, like I was saying, active placement service, runtime injector, etc., run as pods as well. The certificate authority that does the rotating of certificates is also there, and there's something to help with rolling upgrades. Those all run there, and then Dapr is injected into your pod as a sidecar for you. You don't really do anything. There's also the health check kubelet as well, which goes in and checks how is the system, which is very important. And then, of course, through that Dapr sidecar, you're communicating to all these different components. Now, a comparison to service meshes is a question. Now, I like to say that Dapr provides you with a kind of abstraction over very common services, very common pieces that you would want in your application architecture, and allows them to be pluggable, and completely abstracts you away from what language you're using. Like I said, if you can do HTTP post, you can use it. If you can use gRPC, you can use it. Where service meshes might tie you down in a lot of those things, but service meshes do help you with the traffic routing and splitting stuff. Like it does help you more on the network side. The Dapr being hosted in Kubernetes, there's Kubernetes ways of doing traffic routing and splitting and things like that, but service mesh is really focused on that kind of region there, and doesn't give you that abstraction there, which is really what developers care about. But the operations side, where you got to do deployments and rolling deployments and stuff like that, service mesh have more prescriptive ways, and you're abstracting yourself away from these from these clouds or on-prem. I want to get to the demo. Oh yeah, great. So that's a whirlwind kind of breadth-wise view of Dapr. I'm going to chuck it over to Param now to do a bit of a code walkthrough, an example. I think you're on mute still.
Switch you over.
Hey, sorry. Thanks, Jasim. So far, I think more of a theory. We wanted to also provide you with a working model and a prototype, how these things fit together on in a near real world example, going through the code and working prototype. So you can get the code base at this link. So the prototype app that we are going to see today has like three different services, a front end which is speaking to a back end with the state store of Redis, and it also has an RabbitMQ as a middleware. It uses Auth0 as an identity provider, so that when front end calls the backend, it has to first authenticate with the identity provider. Here it is Auth0, and then pass that token back when doing any calls. So the functionality around the system is pretty simple. It's just a generation of an n Fibonacci series, and then it computes a few statistics indicators like mean and median and the standard deviation. So the core logic of the computation resides in the backend, but the front end acts more kind of an orchestrator generating those series, and the backend is supposed to do the computation and then return the result back to the front end. The middleware, the RabbitMQ, is used as an eventing system, wherein whenever the state of the backend indicators like mean, median, and standard deviation changes, it's going to send out an event into RabbitMQ and say, hey, the standard deviation has changed. So, for example, any other app that is listening on this can do whatever changes that it wants to do. So it's the core. The functionality is not so important, but it is tailored to emphasize the fact of or the features of the Dapr that we are going to demo here. So let's, though the prototype actually is coded for both to work on-prem and Kubernetes, I'm going to demo here with Kubernetes, but the code is already present where you can use the same thing in on-prem as an executable as well. Here the demo environment is like I'm running a Docker desktop locally with Kubernetes turned on, and that's where the Dapr system is installed, and all those the front end and back end or Docker containers. RabbitMQ and Redis are also infrastructure services, which are also Docker containers. So if you go to, let me deploy those services. Let's do a test. Let's see how it is working, and then go back to the code to see how things are coded, how things fit together in terms of your service-to-service call, or state storage, or a publish subscribe and things like that. So there are few the project contains few convenience scripts. If you go in here, you can see a few convenience scripts that is used to actually do some processes like installing or port forwarding your Docker containers. So let's start with the install. So this actually, as you can see, it changes the context to Docker desktop because I'm targeting the Kubernetes on Docker desktop. It creates the Dapr namespace and installs your Redis and your RabbitMQ Zipkin for observability as native Kubernetes services and deployments. There's nothing special with the Dapr. It's a pretty normal Kubernetes deployment of containers and services on top of it to provide outside access to the pods. So after that, it actually installs a bunch of Dapr components. We'll go one by one, but those are the specifics of whatever we have seen till now, or the components are pluggable things that you can actually deploy into Kubernetes with Dapr. and then it deploys your the front end, back end. Just ignore this security thing. The prototype is also in progress. So the idea here is to currently it uses Auth0 as an identity provider. So we are trying to swap it to the identity server 4 instead of, so that it can be run on-prem as well. So again, the deployment of these services is not different than a regular Kubernetes deployment, but it has its annotations to hook it up. So right now, all those objects, Kubernetes objects are deployed. The Dapr objects are also deployed, and it says that all things are running. If you wanted to access that, you need to put forward this. Again, this is also straightforward Kubernetes concepts. There's nothing Dapr concepts. So let's start with the test with port forwarding the front end and back end services, so that you hit the front end services and say start generating your Fibonacci series, and then it's going to generate the series, call the backend API, compute, and return the result back. So let's say port forward front end running on 8080. Port forward. Okay. So let's port forward the telemetry as well. So that we can see the front end hitting the back end on a Zipkin. So we'll do a test. So what it has done is it has hit 8080, which is the front end that we have port forwarded. And it has actually gone and generated those numbers, gone back to the back end, come back with the result. So it has, by default, it generates 10, the first 10 Fibonacci series. It has computed the sum. It has computed its mean, variance, and standard deviation. So let's see how this happens in the code. But before that, we can actually look at the Zipkin to know that it really hit the backend. So if you see here, this is the Zipkin result that we have got back for this round trip, and it shows that the front end, and it has a backend call, which is a reset call, but it doesn't have all those calls for the reasons I'll explain later. But essentially, the first level call has been maintained, but you need to propagate the trace context manually, which we have already discussed in Zipkin community, in Dapa community, which they might fix it. So let's go to the code base. So the prototype contains 3 projects, as you have seen here. The front end of the back end, these two are pretty much a standard .NET Core 3.1 web API. So if you see the front end, it has a single controller with a single endpoint exposed. The slash series is the endpoint that is being exposed. That's what we were calling from the test. So this is actually supposed to call the backend with the numbers. So the function here is this function generates a Fibonacci series, and it invokes the backend and then sends that input so that it can do the computation one by one. So sequentially, this call is going to trigger the backend and add numbers so that it computes the backend. The backend computes the statistics indicators. So right here you see the service-to-service invocation. Here is how you do a service-to-service invocation from one service, the front end, to the other service. So the Dapr is the Dapr client, as Jason suggested. They also provide not only these components, but also SDKs in various different languages. So I'm using a C# SDK for Dapr. So all these are pretty much the same. Every time you you send a request, you generate your Fibonacci series and send it to the backend. And once you have sent all the first 10 numbers, you just invoke the backend calls with your count, sum, mean, variance, and standard deviation. So if you go to these calls, if you go to your backend, you can see those calls um, as a simple standard web API. So that's service to service invocation. So by the nature of the fact that you need to store the incoming numbers for computing statistics, obviously you need to use a state storage. So the way in which we use a state storage here is whenever your new number comes in, let's say your input, that's where your new number comes in. You use the Dapr API to talk to Dapr and then say, can you store this piece of data into this database, which I have marked here. So all you say is, this is the data store, and what is the data that you wanted to save. So you say save state async. This is the data store. What is the key for this data, and what is the data that you wanted to store? So if you look at the data store, which is termed as cache, because I'm using a Redis cache as a data store. And if you go into your components, you will have a cache, which is named as cache in the same Dapr namespace, and which is of type Redis, and it has its own configuration. In this case, the Redis is also running inside the same namespace in Kubernetes, which doesn't have username and password. It's an authenticator call here. So I'm just saying here is the Redis and the properties. So that's state storage. So as I said earlier, whenever the statistics indicators change, the backend is going to publish an event, and you can subscribe back. So the way in which it does is using a publish call on the client, on the Dapr client. You have a publish event async API, where you can say what is the middleware that you wanted to publish, and what is the topic that you wanted to publish, what is the event. So here I'm publishing the event as the statistics has been updated, either a mean, median, or mode, or standard deviation. So if you see in the same pattern, if you see what is the middleware that is being used, termed as middleware, you go into middleware. The type of middleware that I'm using is RabbitMQ. RabbitMQ again is present within the Kubernetes cluster. So these are the properties of the RabbitMQ that you can use. So if you can see the pattern emerges, that's the flexibility of those components. And the components can have different properties depending on the underlying infrastructure that the component is referring to. So that's publish subscribe. So when you do a publish, that's how, when you subscribe, it's a little bit interesting. How you do is like, at least in C#, you mark a particular API as a topic, and it actually registers into Dapr system, saying that for this particular middleware, for this topic, if there is an event, then call this as a post. So Dapr calls your API as Dapr system calls your API as a post with this event data. So currently I'm not doing anything. I'm just serializing and putting it on the standard output. So that's pretty much on the major components or the pluggable components. There are a few things that we have also done in terms of middleware for your services, which are before you hit your API. It's more kind of an HTTP middleware that you can add your sets of pluggable functionality before a particular endpoint is hit. So if you see, there are, as I said, the backend has to be, the backend checks that it has been authenticated. So we use JWT token to authenticate the front end talking to the backend. So the way which we do is using Dapr middlewares. Especially there are two specific middlewares. One is your auth client credentials. So the front end uses client credentials to authenticate with auth0. Don't worry about this. You can actually put this on a secret store and reference here as well. But for demo's sake, it is I'm just using it here, and this is not checked in, and it will be rotated after each demo. So if you see here, this is registered as a back-end front-end application in auth0, and this is on the front-end side. When it actually tries to talk to the backend, it is going to authenticate with auth0, use this client credentials to authenticate, generate a token, and send that token to a backend. And the backend is going to use the same client ID to verify if the JWT token that's actually is valid. So these are the examples of two middlewares that you can use. The way in which you can use such middleware is through configuration. So if you see in the configuration folder, there are two YAML files, one for each of the APIs, the backend and the front end. So if you see the backend, there are two middlewares. One is your rate limiting, and the other one is used for authorization and authentication and authorization. So if you see at the back end, it also has a throttler for rate limiting and also has the bearer token authorization. So that completes the demo. Let's check.
Does anyone want to jump in with any questions at this point? I'm happy to voice them for you. Just stick them in the chat. If you want, go on, and we'll wait for any questions, and I'll voice them as they come up. Param, you go on.
Yeah. So yeah, I think that's the status of the prototype that we have. We have the installation and the setup for both self-hosted and Kubernetes. We have the service-to-service invocation, state management, publish and subscribe. We have done secrets and configuration, just the read part. As Jason said, the writing part is still not complete with the Dapr community itself, maybe for the right reasons. We have also included rate limiting and the OIDC middleware. It's an ongoing prototype on our side. We are still continuing to do the observability, the logging functionalities, which you can log in the entire system, and also the containers or the APIs with Elk and FluentD. So yeah, I think that should be the end of it.
Sounds good. Would you have to post those results and also the slides, Jason, as well in the comments for the meetup afterwards, because I'm sure people want to have a look at them. Any other
Definitely.
results? You want to
definitely.
share?
Yeah, I'll share the slides, the entire slides, also the articles and the code base, the complete code base.
That's good. So how did you find the development experience as a developer? Was it a nice setup to work with? What did you think?
So I guess from my perspective, I feel the Dapr is more tuned to starting from a Kubernetes approach. It was more tweaked for a microservices environment, which predominantly these days um, they use people use some kind of orchestration, and they are heavily um, uh, tweaked towards Kubernetes, which is really a breeze in terms of installation. There are some teething issues around on-prem installations and setup, but once you get overboard those installation and setup, pretty much it's a breeze in terms of using it. For us, the major advantage is we play in both on-prem and the cloud space, so that actually gives us a big advantage for us not to use different components and different code bases and different strategies to do the same functionality on-prem and also in the cloud.
That makes a lot of sense. Any other questions? I checked. There's a few resources that that people have put up there. Francis has put a few books up as well. If you're looking at the chat there, and yes, a little bit of information from Mel Shaker on the sidecar pattern. Yeah, well, thank you very much, both of you. I really enjoyed having the the high level view and the architectural view from Jason and the hands-on code from Param. It's been very informative.
Yeah, I did want to mention that the way they're doing the Dapa project is very interactive in terms of steering committees and stand-up meetings and kind of like, reviews of APIs. And if you've got a demo that you want to give the Dapa community directly, they give opportunities. They're really doing this in a very open way. Yeah. So I think they learned a lot from the growth of the community around Kubernetes itself.
Yeah.
And they definitely want to try to bring any kind of because the success of it is going to be not just the ease of use from the microservice world, but also the plugins to other systems. Just having a great community and good feedback is
there's a good community in Discord as well. So feel free to hop on. There's a good lively community there. People talk about all sorts of areas where you can really get involved in the making of Dapr.
That's very good. I should probably go to the giveaway because we're at the end of our time period, really. So I'll just do that one now. So and then if anyone else has any other questions that they want to do, then ask, then pop them in the chat and we can do it afterwards for anyone who wants to stick around a little longer. So first question for you for the first of the two JetBrains licenses is what language is the Dapa config in, or at least the ones that we've seen today? First answer wins the license. Oh, look, I don't know how to say that, but the winner is Mutely Oz, right? Here we go. So just send me a meetup message and I will, with your email address, and I'll send you the license for that. All right, so just send me a message on Meetup with your email address. And for the second question, does Dapa support storing and retrieving secrets from a Keystore or vault? It's kind of a bit of a trick question, so it's not quite a yes/no answer. I think Gareth has got the answer from. Is that right, presenters? You happy with that? Only retrieving?
Only retrieving. Yeah.
Yeah. All right, Gareth. Send me your email address. I might have it already, but better send it through just in case. Francis has said, surely the language of Dapr is fashion, but I somehow think he was not after a license with that answer there. All right. Also, if anyone has any topics they'd like to present on, then please send me a message on Meetup as well. And we've got some slots coming up in future months if there's anything you want to talk about, or even a suggestion for something you want to hear about too. So thank you very much to both our skilled presenters today, and we'll see you again in a month.
Thank you. Thanks, everyone.
Thank you, guys.
Thank you.
Thanks.
Bye, everyone.
Thank you.
Thank you.